Hello everyone, and welcome back to Mr. Anderson's Algebra 1 lessons. Today we're going to be talking about factoring by guess and check and factoring by grouping. And so I have an example for each one here, and you usually use factoring by guess and check when the leading coefficient is larger than 1 and has nothing in common with the other terms. And that's what I see here. 3 does not go into 35 or 50, and so we have to use another method. When I'm thinking about factoring these, I usually find the factors of the leading term and the last term, and I look for the ones that kind of help me meet out in the middle. Now, the number 3 has two factors, 1 and 3, and 50 has several. So we're going to have lots of different guesses here for our guess and check method. So you have 1 and 50, you have 2 and 25, you have 5 and 10, and I think that's about it. So these are your factors that you have. And you're looking for setting up your terms so that you can make the term in the middle. Now, when you factor these into the binomial, your 1 and 3 are what's going to be out in the front because those are the first terms. If you want to think about FOIL again, like we talked about earlier. And so you got 3n and 1n here. And the next step is to kind of think about what are the signs going on inside. And I notice that I have a plus here and a negative there. So that means both of my numbers are going to be negative, because when you multiply two negatives together you get a positive, but when you add two negatives together you get a negative. So that's half the battle. Now the final step is to figure out what two numbers go here, so that I can make my appropriate guess for the guess and check method. And so you are going to be choosing from the 50 category because the last two numbers multiply to give you 50. A quick way to figure this out is mentally using the O and I part of FOIL to see if they're going to give you the 35 in this example. So if you do if you put the 1 here and the 50 there, that's going to give you 53 if you multiply everything through, and that's not even close to 35. If you put 2 and 25 in there, if you multiply 3 times 25, that's 75. And if you multiply 3 times 2, that would give you 6. So really 25 plus 6 is not anywhere near what we need here. And so I can already cross out these two as my guesses. So the remaining guess would be choosing these two. So you could have this as a guess, or you could have this as a guess. Notice how I switched the 5s around and the 10 around. Factor this. And so if you use the O and the I part of FOIL again, you can check to see if it works out to give you the 35. So 3n times negative 5 is negative 15n, and negative 10 times that is negative 10n, and that is equal to negative 25n. So that is a negative ghostwriter pattern is full. Does not work. So let's hope that this one does. 3n times negative 10 is negative 30n. Negative 5 times 1n is negative 5n. That gives you negative 35n. So this is the one we want. So our solution to factor is 3n minus 5 times 1n minus 10. And that gives us the factored form of this guy. So perfect. Awesome. Factoring by guess and check is not the best method, I think, but it is useful in times like these because most of our quadratics that we see in math are like this. So this is a good skill to have. The final example is a factor by grouping example. And so what you do here is basically you notice that you have a term of 4 and you are going to really split it up into 2 separate things. And so you're looking for putting these 2 into groups and factoring out the common factor in each group. So I have my 2 groups and I'm looking to factor them out. None of these things have in common straight up, but if I put them into 2 groups, I notice that they have a common factor here of 7. And I think that's a -7. I'm going to factor that out. And they also have a v squared. I'm going to put a v squared right there. And so that would mean that inside of my factors here is actually, you know what, I'm going to change that. I'm going to make that a +7. I'm going to make that a +7. So that would mean inside my factors here that I have a 4v minus 1. Okay? 7v squared times 4v is 28v cubed, and 7v squared times -1 is -7v squared. So this is kind of important. We want to make sure that when we factor the next set with this guy, that we have this exact term inside our parentheses here. So this one, I'm noticing that I have a 5 in common. And I'm going to factor out the 5, but in this case, I'm going to factor out a -5. And so when I factor out -5, that means I have a 4v minus 1 inside. And see, notice how I have the same terms here? That is going to be used later when I make my common binomial factor here. So how I find my first binomial comes from the top, these 2 out here on the front. These make up my first binomial. 7v squared minus 5 is my first binomial. And my second binomial is 4v minus 1. And so that's my factored form. Now, to prove that this is the right answer, I'm first going to add all of this like term together. But I don't need to because all of these are in descending order, and so that's what it is. If I multiply all this through using the FOIL method, I should get this term back. And so that's what I'm going to do to check. Multiply the outside and the inside and the last terms together. And so first 7v squared times 4v, that is equal to 28v cubed. Oh, off to a good start. 7v squared times -1 is -7v squared. That's good. That checks out. -5 times 4v is -20v. And -5 times -1 is +5. So this actually checks out to what we got in the beginning. And that proves that I factored it correctly. This has been factoring by guess and check and factoring by grouping with Matt, and I hope that you enjoyed this lesson and you learned something from it. Again, I wish you luck and have a nice day.